For centuries it has captivated man's curiosity. We have always stared up in the sky in wonder. The seemingly infinite vastness has given us both a sense of purpose and the lack of it. The desire to know what's out there, how far we can go, has given rise to some of the most amazing technological advancements of man. Telescopes, rockets, satellites, the moon landing. Even now, we have people orbiting our planet in the International Space Station, looking, searching. So, how much have we found? How do we explain these things to others when there are gargantuan numbers involved? We use scale. Since the beginning of the concept of teaching the science and math of really big and really small things, humans have used scale. Phrases such as, it was 10 times bigger than this, or it was half the size of that, all relate to scale. You can scale nearly every aspect of a thing: size, weight, width, volume, height, and we can use this, and the math involved, to easily understand the size of our solar system, our galaxy, and the universe around us. Here's a picture of the solar system. Kind of, but not really. The difference between the planets and their sizes isn't really accurate. Let's say we wanted to scale down the solar system as small as possible. We'd probably want to use a scale of about 1 billionth. 1 billion is a very large number, but conceivable. Let's start from the Sun and move out, using our scale of 1 billionth for both the size of the planets and the distance between them. The Sun is about 1,039,000 kilometers in diameter. Using our scale, our model Sun would be about 1.4 meters across. The next planet, Mercury, is about 57,909,000 kilometers from the Sun. Scaled down, it's about 60 meters away from the Sun and about half a centimeter across. The next planet, Venus, is about 108,200,000 kilometers from the Sun. Scaled down, it's about 50 meters away from Mercury and about 1.2 centimeters across. Our planet, Earth, is about 149,600,000 kilometers from the Sun. Scaled down, it's about 41 meters away from Venus and about 1.3 centimeters across. The next planet, Mars, is about 227,940,000 kilometers from the Sun. Scaled down, it's about 78 meters away from Earth and about 7 millimeters across. Next planet, Jupiter, is about 778,400,000 kilometers from the Sun. Scaled down, it's about half a kilometer away from Mars and about 43 centimeters across. The next planet, Saturn, is about 1,423,600,000 kilometers from the Sun. Scaled down, it's about 645 meters away from Jupiter and about 12 centimeters across. The next planet, Uranus, is about 2,867,000,000 kilometers from the Sun. Scaled down, it's about 1.4 kilometers away from Saturn and about 5 centimeters across. The next planet, Neptune, is about 4,488,400,000 kilometers from the Sun. Scaled down, it's about 3 kilometers away from Uranus and about 5 centimeters across. The last planet, Pluto, and yes, by the way, Pluto is a planet. I don't care what Neil deGrasse Tyson says, we're putting it in, so get over it. Anyways, Pluto is about 5,909,600,000 kilometers from the Sun. Scaled down, it's about 1.4 kilometers away from Neptune and about 0.2 millimeters across. So, if we were to look at this model as a whole, it would be about 6 kilometers across. And we couldn't make it any smaller or we'd start losing planets to the naked eye. Now, that's considering the solar system as a line, like in all the diagrams. But the solar system is actually a sphere. All the planets orbit on individual axes of a circle, which give us about a 12-kilometer sphere. But there are other solar systems out there, so our next logical step is to scale our galaxy. And what are we going to use? Marbles. Our solar system is about 12 trillion kilometers in diameter. So for our next model, we are going to use a scale of 1/4,000,000th. To put this in perspective, if we were to scale a single atom up 1/4,000,000th, it would be more than 30 kilometers across. This scale brings our solar system down to 1.2 centimeters in diameter, about the size of a marble. According to the scientists at NASA and other spacey places, every solar system that we've found is about the same size as ours, so we're going to just use identical marbles in our galaxy. On average, solar systems in our galaxy are about 75 quadrillion kilometers apart. Scaled down, that's about 70 to 80 meters apart. How many marbles would we need? How many solar systems are there in our galaxy? 200 billion. Again, thanks scientists for figuring that out so I don't have to. That would be enough marbles to be stacked to the moon and then some. That many marbles would weigh 1 million metric tons, the same as 3 Empire State Buildings, 182,000 African elephants, or 5 million sumo wrestlers. For our galactic marble model, we would need 1 billion square kilometers, about half the Earth's surface. If we really wanted to, we could scale it down a bit more and use sand. But if we're going as small as sand, we might as well go for the big cheese, the known universe. In order to do this, we're going to scale our entire galaxy down to the size of a grain of sand, so we're going to need some important information for scaling. First of all, 1 light year is equal to the distance a photon of light can travel over the span of 1 year on Earth, or about 9.5 trillion kilometers. I should also note how one measures the distance between galaxies. These distances listed are the space between galactic centers, which just means the distance between the centers of the galaxies. Now, the diameter of the Milky Way Galaxy is about 120 light years. So we're going to use a scale of 1/septillionth, which would scale a single atom up to the point where our solar system could fit inside it. This brings the diameter down to 1.2 millimeters, about the size of a large grain of sand. How big are the other galaxies around us, and how far away are they? The closest galaxy to ours is the Canis Major Dwarf Galaxy, which is inside the Milky Way. Its galactic center is about 25,000 light-years away from the Milky Way. The next closest galaxy is the Large Magellanic Cloud. Its galactic center is about 179,000 light-years away from ours. The next closest galaxy is the Small Magellanic Cloud. Its galactic center is about 210,000 light-years away from the Milky Way's. Comparing these galaxies and a couple others scaled down to 1/septillionth, we get an average of about 2 millimeters between our galaxy grains. We can also assume our sand grains will be about the same size, as the difference between galaxies scaled down will not really affect the sand to a point where it matters. If you want to measure and cut grains of sand to exact dimensions, be my guest, but I don't wanna. So, how do we figure out how much sand we need? The number of known galaxies in the universe can be extrapolated from the Hubble Ultra Deep Field, taken over a time period in 2003 and 2004. A satellite pointed at a single piece of space for several months, a spot covering less than 1/10 of 1/millionth of the sky. Hubble returned an image of 3,000 galaxies. Using some basic calculations, we can assume our number is 300 billion galaxies within the known universe at least. There's probably more, but this is what we know of. Now we need to arrange the sand. Unlike our other 2 space models, the universe is 3-dimensional, so we're going to have to arrange our galaxies in a 3-dimensional grid pattern of some sort. For ease of calculation and understanding, we'll use a simple box grid. In order to calculate the volume and dimensions of our model, we need to know how calculation of the grid works. The formula is pretty simple. Our volume is 2,400,000 liters, the volume of an Olympic swimming pool. So how much would all this sand weigh? Assuming our galaxies are all about the same size, about 300 metric tons, or 55 blue whales worth. The great thing about this particular model is that our galaxy would be located right in the center of it. So there you have it, the entire known universe scaled down so that it could fit on our planet. We can use scale to model the impossible and fit our entire universe into one room so it can be understood. All that's left now is cleaning up all those stupid marbles. Damn, that was a bad idea.